Michael McDonough will be discussing a device that utilizes a sacrificial anode, which is eroded into a self-compressing plasma vortex to create a low-energy nuclear reaction. It's a type of fusion that can be used for energy generation. He'll be discussing the method of operation, test results from past experiments, and possible methods of propulsion based on this technology. So most of you probably aren't familiar with Michael McDonough. I've known Michael for probably 17 years now. He used to have a startup company that was working with a lot of these technologies. And so he is a wonderful and brilliant man. I'm so appreciative that Michael joined us. So Bernie, I'm going to put your hand down, and let me see. Michael, I think that we have you with us. I will spotlight you, sir. And
how's
again,
everyone?
Doing well, and thank you for joining us.
Do you have my slides ready, or do I need to do it, or?
What would you like to do it? Do you want to do it as a screen share?
I haven't actually used this type of interface before for that
Well,
purpose.
so what I would are you on a PC or iPad? Oh, Michael, you just muted yourself. Hold on just a moment.
Unmute. Okay.
Okay, yeah. You said you're on an iPad?
No, I'm on a cell phone.
Oh, okay. Yes, let me do that. Let me pull your slides down then. Yeah, the cell phone would not work for that.
It's kind of a one-trick pony cell phone anyway.
Yeah. Okay, so edited slides, and I'm gonna bring these down. Okay, so I haven't done this in a little while, but let me do this. I'm gonna share my screen. I'm gonna put it on Plasma Vortex Fusion. And hopefully, can you guys see this okay in Zoom?
I can see it. It's not perfect, but
you know what?
Seeable.
Here,
if you put it into what do you call it, mode? There you go.
Yeah, now it's full screen mode. Okay, so yeah, hopefully this is recording okay.
All right, I'm going to go ahead and just say it because you're recording it.
Yes,
this
sir.
is hydrogen plasma vortex induced light metal nucleonic reactor propulsion. In the system described, a hydrogen plasma vortex is created in a vacuum chamber as hydrogen gas is fed into it. The resulting pressure gradient of gas volume forms a suction head at the anode site, causing the metals to boil off and fuse, releasing energy and fusion-produced ions, which are drawn off and used. In this work, a nuclear chemical process is recreated from cosmogenic observations in the experimental device presented on slide 2. And the initiation of a hydrogen plasma vortex as it ablates the light metal anode under conditions of high voltage, low frequency, low temperature, a protium-containing non-equilibrium plasma, specifically a lithium, beryllium, and boron-containing magnesium aluminum anode is ablated. The reaction area is surrounded by an inductive coil, and added conductive elements are placed in order to shape the resulting E field to induce the vortex to compress at the anode site. As the gas and energy are released, the suction head moves about the anode, continuing the reaction until the anode is ablated and the fusion products move to the cathode. And you can go ahead and go to the second slide. All right, in the second slide here, as you can see, at the top, the silver cathode, it's what you see just at the very top of the center of that image. It's made out of like a silver coin in this particular instance, but it's shaped in kind of a vortex shape, which helps to create the initial vortex stream of energy to flow down the cylinder that you see here. And that hydrogen plasma vortex is what you see that is a kind of a violet color. That's the hydrogen plasma vortex. The reddish colored material around it, that's a solenoid wound coil that wraps around the vortex chamber, and that reacts to the plasma and generates an electrical current, which tends to squeeze the vortex down toward the anode. The anode at the bottom is where you see the bright flare on the arrow that shows as fusion. That is the light metal anode, and the important elements in it are the beryllium, boron, and lithium, which I'll explain later. In this particular prototype, which I still have in my possession, we're using it used a 20 kilovolt electrical transformer, like typical for a neon transformer, and it used a 60 cycle square wave input, and it was only using 40 watts. It was tested in a thermal bottle type of device, which looks for the amount of heat increase, and with a 40 watt 12 volt input, we were getting 280 watts of total heat energy output. So 7 times over unity for a 24-hour period while it was being run within the thermal chamber. Visible light energy was not tested, so it achieved 7 times over unity without even measuring the visible light that was produced by the plasma. So in my consideration, that generated nuclear level events within the plasma. Go ahead and go to the next. This is a WIPO patent image, World Intellectual Property Organization, of the plasma vortex chamber that you just saw in the previous slide. It basically just shows an outline of the elements that are involved, the coil in the center, and the anode and the cathode on either end of the tube, and his placement of the hydrogen bottle and all the other components of it. Go to the next slide. Yeah, there you go. This shows the plasma vortex flow schematic. In the top element, the hydrogen is induced into the reaction chamber. On the lower level, you see the plasma form between the cathode and the anode, and in this particular instance, the anode is hollow, which allows the gas to pass through. And this is just kind of a typical representation of a plasma vortex going through a tube. I just use that for demonstration purposes. Go to the next slide. The other direction, your other direction. Thank you, sir. This is the 3D layout of plasma vortex drive. This is my initial form, my preferred embodiment of the engine. On the left side of the screen, you see what is the injector site. This is the hollow sacrificial anode, which is shown in the colored area. The areas that are gray, those are basically made out of Maycore ceramic, which is it's as strong as steel, but it's a machinable ceramic, which I've already purchased. I intend to take the material that I have already invested in the initial prototype and split that down into 4 of these tubes, which will be designed to go into like a 6U type satellite, satellite configuration, so that we can test them in space. And I'll be looking for some funding for that. Go to the next slide. In this one, I'm showing what most people don't understand when they're looking at, say, for instance, a tornado, or in the case of this plasma vortex that you saw in the cylinder, is it's actually a toroid. When we look at a vortex, we see the vortex, but what you're actually seeing is the area that's down toward the center of this. And in the center, that area is what's visible on a tornado. And the same thing with the plasma vortex you saw in the tube. What you don't see is the outer part of the toroid. And in the bottle that you saw in the second image, that coil acts to flatten out and compress what is naturally this rather stretched out toroid shape, which is what you're actually looking at when you see a toroid, or in this instance a tornado. Go to the next slide. All right, in this slide you see toward the left hydrogen and helium. This is the abundance curve of elements that in the observable universe. You see right after helium, lithium, beryllium, and boron. There's a deep dive down in the abundance curve. There's a reason for that. And Ari Degas, among other scientists, found out that the reason that there's this massive dip in the abundance curve is that all of these other elements that are in the second area that starts with carbon and nitrogen and oxygen, those are formed in the toroidal vortexes that surround the star. Stars are formed by helium and hydrogen being compressed into lithium, beryllium, and boron. The lithium, beryllium, and boron actually, as it is formed in the star, form at a much lower energy level in the corona of the star, in the vortex filaments that surround the coronosphere of the star. All of them that you see from basically from carbon to nickel and copper, those are the ones that are produced in the toroidal vortexes in the surrounding area of a star, and also in every other sort of vortex type of plasma filament in the universe that generates all of the heavier elements. So what Ari Degas has discovered, and what we're going to be utilizing for star drives eventually, is being able to use that low energy nuclear reaction of lithium, beryllium, and boron, and forms the heavier elements that are on the periodic table to power our star drives. And because of the Schwarzschild, what do you call it? The right term. The
Schwarzschild radius or metric?
No, not the metric. The Megas effect. There's a Schwarzschild Megas effect. The Megas effect is what causes the low energy nuclear reactions. The spinning of the vortex, the apex of the vortex, where it strikes the elements that are being fused, that vortex, that compressed area, there's a Schwarzschild Megas effect at the rim of the vortex, and that's what causes the low energy nuclear reactions. It's because you've got all of the electrons on one side, all of the protons on the other side, and they're flattened out at a extreme angle at that place, and that creates a collapse in the Coulomb barrier, which is why you're able to have these low energy nuclear reactions at amounts of energy that are unexpected. When we look at fusion reactions, we're looking at helium reactions, or helium hydrogen, or one of these, helium hydrogen lithium, the very low end. Those reactions actually require a lot more energy than beryllium and boron. The lithium is a little bit less, but the beryllium is the lowest, and the boron is the next to the lowest as far as the amount of energy that is required for it to fuse into the heavier elements on the periodic table. Go to the next slide. On this one, I'm just basically showing that and I did change that powerful to 1L anyway. the vortex is the most powerful force in the universe. Everything that all matter is formed in vortexes. Photon geometry demonstrates vortexes. All atomic structure are toroidal shape. Everything in the universe is a toroid. You know, everything down to the atomic level, all the way out to the universe, and everything in between. And that's my presentation.
Okay. So let me do this then. Let me stop sharing. Okay, and so actually that was really fast, Michael, but thank you. So let me go into the Q&A session. And I know, again, you and I talked about this for many years. You know what, here, I'm going to remove spotlight. That way we'll go back to normal. You and I talked about this off and on for many years. So one thing, let me ask, you actually did testing and you had results. You had fusion reaction products, if I understand right.
Yeah, we have the mass spectroscopy imaging that we got from the University of South Carolina that showed the K40 potassium 40 spike, which volumetrically was 98% of the sample, which means of the scrapings off the cathode, a little bit was silver, a little bit was silica, boron, other things you'd expect inside of a glass cylinder. But 98% of what we scraped off the cathode was pure potassium 40 isotope, which is impossible. You can't buy that. You can't buy 100% potassium 40 isotope anywhere on the planet. You just can't. It's normally 0.00019% of all potassium on the planet is potassium 40 isotope, and that was produced in the vortex ring of a supernova billions of years ago, somewhere probably in our galaxy. And it got here by supernova. It was brought here by the galactic wind, and that's how we got the potassium 40 that's on this planet, except for what was produced by this device. The stuff that's produced on this device is brand new, 100% pure synthesized potassium 40 isotope, which is impossible any other way other than low energy nuclear reaction to create newly synthesized potassium 40.
Awesome. Thank you for sharing that. That's it. And I remember bits and pieces. We talked about this for several months, like, again, probably 15 years ago, 17 years ago. And so very spouty on it. But
it was a situation where, I was working to try to find something with beta voltaic that would make it where we could, like nowadays, they have a beta voltaic that's getting some funding, which is interesting because they're doing a system that I actually envisioned, decades ago, but wasn't possible then. Now it is, of course, and so now it's doable. But in that technology, we were looking for something that was doable now, at that point. And with the information that I got, it showed the low energy nuclear reactions that, to me, 7 times over unity, that's verifiable in an independent lab result, and nuclear products which cannot be any other way produced other than what has been described, what has been shown to us. I mean, it wasn't even humanly possible to have potassium 40 of that purity anywhere on the planet. So that was evidence, all we need, that I had a good investment going. Problem was, the investors, and that story. Basically, they decided they wanted to have new Firebirds and fancy cars and stuff, instead of giving the money to the people who would actually be making prototypes and making money for them.
Yeah. Well, so let me do this. Let me go to Phil Bouchard first. Phil, I like your shirt. I like the band. Oh, and you know what? Hold on. Sorry. Let me allow participants to unmute themselves, and I'll ask you to unmute. Lower the hand. There we go.
All right. Thanks, Tim. Sorry, I'm not really prepared. I look like Einstein with my hair right now. Spiky here. I just wanted to say that it's very interesting presentation. We're doing, as you know, research on the gravitomagnetic force, and all that is required is a spinning ions. We were looking into cyclotrons, tokamak, and things like that, and your device looks perfect, I think. So is it possible to have a device of yours with just continuously spinning ions in it?
Yeah, it's the plasma vortex will continuously decompose the solid metal anode, and the anode can be moved up into the plasma chamber through something that essentially moves the rod, or the cylinder in this instance, into the chamber as the reactive material is decomposed or ablated. It's super efficient. The amount of hydrogen that we were seeing produced in the prototype was remarkable. It was beyond what you could even calculate for, like partial decomposition into other fusion products of hydrogen, like as an excess molecule from two different metals being, fused together, and then an excess hydrogen being knocked loose. It was difficult to explain where the extra hydrogen comes from. That was one of the reasons that I started looking into the Schwarzschild Magus effect, is that with the Magus effect, if you're familiar with that, how like a spinning ball, if you throw a ball and you spin it down a mountainside, it will float away from the ground. You know what I'm talking about?
Yeah.
That's the Magus effect. A spinning object is repelled or pushed, it gets, it moves away from the area that it's spinning, unless you rotate it the opposite direction. Then it acts like a suction, and it is compressed towards what it's spinning near. So in one direction, Magus effect has an attractive force. The other direction has a repelling force. And in this instance, the Magus effect has an attracting force in the suction head of the plasma vortex. That's why it will collapse the Coulomb barrier, which is supposedly the strongest thing there is. Well, it's not stronger than the Magus effect from the Schwarzschild metric that is produced by a vortex. The vortex is infinitely compressible because the vacuum of space is infinitely compressible. I don't know if you're familiar with Nassim Haramein and his work.
Yeah, well, I mean,
Nassim Haramein is, his cosmological representation is very similar to my cosmology. He believes that the universe is toroid shape, and that the universe is basically the galaxies on the outside of this toroid, and that it goes toward the center. There's a big bang, and then at the top, and then the universe goes around, and then it is recycled over and over again. Anyway, that's the Resonance Foundation. That's part of his thing. But in it, they discuss the Schwarzschild Magus effect as being what gives us the ability to use black holes for moving from one part of the universe to another, like star travel. And so this plasma vortex technology, even though we're doing it on a micro scale, we'll be able to, now we have instruments we didn't have 15 years ago when I first investigated this. We'll be able to detect things on a level that we couldn't possibly do before. And if it's correct, and what I'm thinking is correct, what's happening is something like a mini black hole or a wormhole opening up, and quasi-particles, which are basically particle, half the particle from this universe, half of the particle from the anti-universe, combining to form real matter, like a negative and a positive quasi-particle becoming a real particle. I don't know if that makes any sense. That's the best I can describe it, though.
Okay, but
A
yeah,
universe.
but I would definitely be interested to measure the gravitomagnetic force that it generates.
And guys, if you can give me 2 seconds, I have to use the restroom really bad, so I will be right back. But
I'll do that.
okay.
You don't get any younger.
Yeah, so like is your device is it like stable, robust, and everything?
Yeah, so long as the pressure gradient remains in the tube, it will continue to create a vortex. You have a pressure gradient caused by the two elements, which are the sacrificial anode is composed of electronegative material. In this instance, the carrier is aluminum and magnesium. The target elements at the erosion site are the beryllium primarily, with lithium and boron. But the beryllium is the primary thing that's decomposed in the plasma vortex. And beryllium is it has a fantastic neutron absorption cross section. That's why beryllium is able to be converted directly into like boron. And boron has an extra it has a extra neutron in a reverse order of a normal neutron, so it works like a suction head for the next thing. That's why boron is so easy to fuse with hydrogen. You know, you get a hydrogen boron reaction to create 2 helium very easily. You know, I don't know if you've done any research into fusion physics, but especially aneutronic fusion physics has been my real specialty area, because that's where I saw, you know, unless we could figure out free energy, which, you know, I'd love to have that. Right now, I'm looking at, you know, how can I have fusion energy, you know, so I have, you know, nuclear level energy in a very small device.
Have you heard about the CFS.energy? They have a CFS.energy. They have a small tokamak shape. Apparently, they create more energy. They have more energy in output than it requires to, you know, to feed the as input. So they kind of creates energy. They're still in a.
Well, technically, the plasma vortex has 7 times over unity in the unit that I tested, and that was not an optimized system. Literally, that means that in this instance, 40 watts of energy went in, 40 watts of DC electric 12 volt went in, and 280 watts of heat, thermal energy came out. So technically, 7 times over unity, 40 watts of energy went in, 280 watts of thermal energy came out. If you'd done a direct, like, you know, if you took a thermal element and just, you know, heated it up with 12 volts and 40 watts, it would have produced 40 watts of energy, you know, if it was 100% efficient, which it's not going to be, obviously.
Yeah,
but
awesome.
For this to produce 280 watts of energy with 40 watts of input, that demonstrates 7 times over unity, which is really good considering how inefficient the whole thing was. I mean, it wasn't even designed to be efficient, but that demonstrates nuclear level events that are happening, similar to like the Pons-Fleischmann, you know, cold energy, you know, cold fusion stuff. They didn't detect, I mean, they weren't able to harness that as a usable amount of energy. They could demonstrate it You know, they put in X amount and they get out X amount in the same way that we tested this unit. Just like with the cold fusion with Pons-Fleischmann, there's anomalous heat produced. The anomalous heat is usable, but in the instance of like with Ari Degas and his technology that we were licensing, he didn't get that world patent, you know, that I showed in the image on the presentation. That world patent, the World Patent Authority did not give him that patent. They said that it had no utility. And technically, as far as the patent office is concerned, it had no utility. In other words, being able to produce 7 times over unity heat doesn't mean anything. It doesn't give you anything. You see what I'm saying? I mean, it's not like closing the loop. Closing the loop is a whole lot harder than just generating an anomalous amount of energy.
Yeah.
Producing an anomalous amount of energy is it shows you that something's happening worth looking at.
Yeah.
But as far as being able to use that, to be able to put it to work, you know, to be able to make a machine that will make something happen, it's a different story. And, you know, having even 7 times, that's 700% over unity. It's still not enough to close the loop. You know, it takes a lot because there's so much loss. When you transfer energy from when you up or down the voltage, when you up or down the amperage, you know, when you change the frequency, you know, when you change the shape of a waveform of a light pattern, you change the energy, you scatter it or you focus it. You know what I'm saying?
Yeah.
It's like with a lens can scatter it, can scatter energy, or it can focus it to a tiny beam. And if that's usable, then it's useful. You know, if you can focus it to a point and your energy can do some work, now you can get a patent and you can make some money. But that's the way it is in the world. It's like you don't get a patent for something that's interesting. You get a patent for something that can be put to work and can make some money for somebody.
Well,
You know
Michael, if I could jump in really quick.
Sure.
As I recall, you were working on a way to extract electrical energy from it. Is that correct?
Yeah. What we were looking at was the energy from the plasma itself that is detectable in the solenoid wound coil. Now, the inventor, Ari Degas, said that the coil was there to gain a charge, you know, to induce, it was inductive, it was inducing a charge from the plasma. And then that created like a prolapse of energy back against the vortex itself, which compressed the vortex and, you know, caused it to focus on the apex of the chamber, you know, to be able to erode the sacrificial anode. So we weren't tapping that. He wasn't interested in tapping that directly. My question to him was, if you're using that energy, why can't we use some of that also? And he was like, well, untapped, it is able to hold a charge, and that charge, because it's not tapped, acts like a choke. Does that make sense?
Yeah.
As soon as you tap that coil, you pull the energy off that coil, you reduce the size and of the electrical area, you know, the energy area around the coil is reduced as the energy flows out of the coil. If it's kept in the coil, we can detect it, we can measure it, but it also stays there. The energy stays there, and it serves to compress the energy in the plasma to the point of focus on the anode. Does that make sense?
Okay. Yeah, I'll need to review all that, but I don't want to block the others. But do you have a website or a way to communicate, an email address?
Yeah, Tim has all my information.
Yeah, and you know what? I actually let me paste that in chat right now. So let me do this. Phil, thank you, sir. Let me go to Bernie next. Bernie.
Thank you. Just like to say that's amazing work, Michael. I do some electrolysis experiments myself, and wondering how often you encounter self-organizing sort of features in the results of the anode, as well as any precipitates and particles that form out of the fusion.
Mostly the fusion products are attracted to the cathode. The anode displays eroding behavior, which can become polymer, like from the erosion site. We looked at the pitting at the erosion sites on the anode, and it showed nuclear level of events in SEM imaging, and I have that data still. That it created some filaments, it was kind of odd looking. When you do a close-up SEM of the places on the anode where the plasma vortex would erode it, you'll see filament buildup going upward toward the cathode, which is basically just the boiled off elements in their various states of being boiled off and fused in the little, like the eddy currents, the edge currents of the vortex, as it's going in and out of the little lip curl, on the vortex itself.
Yes, that's awesome. In my personal experiments, I often notice what seem to be nanotubes forming, as well as constant vortexes in the water between what Gerald Pollack calls the EZ zone, the exclusion zones, and there'll be like an inch full of nanomaterial and then an inch of just clear water, followed by another inch of particles, followed by clear water. And in the structure, there always seem to be forming these vortexes spinning into the center of each other. It's quite fascinating. So it's cool to hear similar sorts.
Yeah, you would see that, because the bubbles form in a column. They don't form individually, and that bubble column is going to create like the little dendrites, little dendrils. As the bubbles come up, they'll form little dendrils of solid material, which will ablate or plate out of solution and form into like cylinders, like you're describing. In a vacuum, it's really interesting because you get really long filament, and I can just imagine. I would love to do the same experiments, and I'm going to. One of the things we're going to do is I'm going to take the material from the that first device that you saw in the images. I still have that. I'm going to divide that anode material down into quite a few, at least 4, maybe 6 devices, smaller devices, and that way I've got for sure. I mean, I've already got the anode sampled, so I can reproduce it. But I want to use the actual anode for my spacecraft. I'm planning on producing a 6U satellite, for testing these engines. I'd like to do one of them initially with borosilicate glass for the reaction chamber, and then I'll use the Maycore ceramic for all the other parts. But the ones that I use for space, I plan to do all 100% Maycore ceramic, all machined out of it, and then launch those into space. And I'd like to do 2 of them. That way I got at least some redundancy. And my aim is to do 2 in a 6U package, and have all the sensors I need, to be able to look at it in space and be able to measure not just the whatever micronewtons or whatever that it produces. I'd also like to be able to see how it acts, how the materials hold up in space environment. because I've been doing a lot of research on that. I think I can produce a pretty good high durability satellite engine using the plasma vortex technology. And it'll last for years. I mean, it'll have enough hydrogen reaction mass generated from that anode to last for a decade, you know, in near Earth orbit easily. And the same thing goes for like a deep space mission. If I wanted to do a deep space mission, it would take a while to wind up in a small platform like that, but you know, I think I could even get escape velocity from these things. It might take more than 2. It might take like 4, you know.
Just quickly, have you ever looked into or heard of Walter Russell's work with the vacuum tube transmutations he was getting in his research with Bell Labs and Westinghouse back in the days with Nikola Tesla? Because it sounds like pretty similar style of experiments that from what he described as what you're doing with the cathode plasma vortex.
Yeah, I actually did a lot of initial reading on that back in the mid 1990s. I don't know about you guys, but I kind of was raised in libraries. When I was a kid, there wasn't such a thing as the internet. I was one of those people who lived in libraries for most of my life, and the internet freed me a laptop, and I was able to get out of the library, get out into the real world, you know, and see other people. But yeah, I actually I moved to Dallas, Texas, years ago when I was doing research for my first book, the UFO Technology Hacker's Manual. I moved to Dallas because I started a company, advanced research projects, like the government thing, Advanced Research Project Agency. Anyway, this is before I even thought about doing anything to try to show up on the internet. But anyway, advanced research projects, I did patent research for a couple of lawyers, and they would write patents for their client, and I would do the legwork. So I had to move to Dallas because the only way to get on and look at the patent archive was to go to the microfiche at the big public library in downtown Dallas. That was the closest one to me. And it was there when I was working for my company, ARP, working for these lawyers doing patent research, that I started doing research on solid state drive systems. And that's when I came up with the UFO Technology Hacker's Manual, because I started noticing that a lot of the artwork that I was looking at sure looked a lot like UFOs. And so I wrote that book, and I kind of become quasi famous for those days. I went on sightings on the radio and X-Files, and I was on Tim's show, and Tim did a couple of interviews with me, and I started Beta Voltaic Industries Inc., and I've done a bunch of other small companies since then. It's basically just been me exploring, the edges of science. And I actually wrote a couple of science fiction books. I've got one of them up on the internet on Amazon called Quantum Fire Control. In Quantum Fire Control, I basically took most of my present ideas and compressed it into a short story, as though it got funded and I had the resources to actually see all these things happen. And so I wrote a fictional story about it, and it's pretty good. I've had a lot of good feedback from it, and it's up on Amazon for 99 cents for the first chapter. I wrote a couple more. What's that?
I've got more homework now. Another book to read. Bless your soul.
It's only 77 pages, but I crammed every idea that I had at the idea 2 years ago into that book, into that short story. And I wrote like 4 chapters. like for instance, this presentation, I had to send 3 copies of the presentation. I found errors in it all the way up to the last minute. And I hate sending anything with errors even to my editor. It's embarrassing. I'm like, oh, you genius, look at that. You put 2 L's under control. You know.
Well, and Michael, I should apologize. I think I think you kept sending me like final version. So I think I grabbed the wrong final version, but
I'm bad about that. It's just that's why I take forever to send anything. It's like I always find mistakes.
Is it called recursion?
What's that?
Is it a system that you've created? It's called recursion, where it's like embedment of a cryptograph or an image, in particular a digital image, and you vortex it any way you want. And you create that, space between the first visible solid and the second visible solid, unlimited amount of universes.
Well, we do live in a multiverse.
yeah.
Oh, I know.
Okay, so let me do this. Let me go to Mr. Riken, who has been patiently waiting, and Will, go for it, sir.
I don't have anything particular to add to what's already been said, but I do have questions, and the questions are really fairly simple. Have you published any academic papers, or have any academics that you have been working with published any papers on your device or your work? And second, has Edward Storms ever commented on your work?
Who are we talking about?
Yeah,
Sorry, that was directed to me.
Yeah, that was for you, Michael. And Edward
Sorry.
Storms. Will, can you elaborate?
Dr. Storms is one of the preeminent researchers in LANR and even coined the name LANR. So I was, since that was in this presentation, I wanted to see if he's actually made any comments. I happen to know him.
Oh, okay.
Someone who we're discussing low energy nuclear reactions. Is that what you were saying?
Yeah, and he was. I think he was wondering about Edward Storms as well. If he had any comments, if he'd approached him, or anything along those lines.
I haven't approached or discussed this with anyone for years. I've been doing for the last 10 years. I've been doing research into the carbon nanotechnology, and I've kind of grown away from the low energy nuclear reactions. I studied the low energy nuclear reaction area because we were looking for reasons for the anomalous heat that we were seeing in several of the technologies we tested for our company. And that's what made me even start looking into it, because it was such a I don't know what's a proper term. People didn't believe it, like with Pons Fleischmann. I mean, there was so little belief in it or acceptance of it. I wasn't in a position I could spend someone else's money and approach or get funding for things that didn't have some kind of verification of workability as far as something that could make somebody $1. I'm a big fan of sciences, of very basic sciences, even especially the cutting edge stuff that doesn't have a lot of track record behind it. But anything that I'm going to show to investors, I've got to be able to explain it to them in a way that is going to make sense to them, and it shows that I've demonstrated that I've done enough research. I'm not going to portray some fraud on them. you know,
So,
and take your
so
money.
that does mean that you have published works in the academic community. You mentioned that you were working with academics to get your data.
Yeah, in order to, I have an ability to see things on a level that is not material or physical. I can see things. I can leave everyone that is pretty much stuck behind their eyeballs, right? Well, I'm not. I'm able to move my consciousness from one place to another. And in order to explain what I'm seeing at the subatomic level, I look for scientists which have demonstrated to me in their work that they are seeing things as I see them. And I'm seeing them physically, not mathematically. I don't have I had to learn the math in order to explain what I'm talking about to people who do know what they're talking about. And what I was trying to explain to them is what I see in my mind's eye, my capacity for being able to change the location of my consciousness to expand or contract to any level. I can go down to the subatomic or out to the multiverse, and by shifting my consciousness itself. And that is something that I've had to try to learn how to do. How do I navigate this? So I look for people who have an understanding of something the way I see it, and then I learn the math and the science about what I'm seeing objectively through their eyes, because they're able to perceive it and communicate it at a level that they can talk to other people about it. And that's where I find myself in my life, and have for years, is, I'm able to see things directly in the universe. Now, how do I explain it to everyone? Well, I have to find people who can also see things the way I do, but they have the capacity, they've reasoned through, and now they can explain the things that they see in their mind that I see, and now we can share it with other people.
So other than the patent, there's no published works?
Well, Ari Degas has published, Tim, do you have all of his stuff? I think you guys...
I would have to dig. Yeah,
okay, he has a fluidium mechanics, or he had some fancy way of saying it, but Ari M. Degas, it's a fluidium mechanics. He has a book and an introduction to a book, both of which are available online for free now, which costs a lot of money when I was buying them, back in the day. But how it is nowadays with academic works, if somebody gets a copy of it, they're going to publish it somewhere.
And that contains your device?
The device is described in one of his published books.
I see. Okay,
and he did file for a world patent on it. He was rejected for the world patent, but I did show you in one of those slides was the world patent that he filed on that device.
Okay, thank you very much.
And thank you, Will. Okay, so let me see. So I think, was that it for hands that are raised? So we have just a few minutes left if we have any other questions. And again, we're running ahead of schedule, but that's cool. And we have Mike Gamble with us. Mike is up next. So let me see. Oh, David, go ahead, sir. And could I ask you to turn your camera on? There we go.
So thank you, Tim. Yeah, great talk, Michael. Thank you.
Oh, you know what, David? I'm sorry. Yeah, you might want to turn your camera off, actually, because you're here. Let me stop your video.
Can you hear me now?
I can. It looks like you're really low on bandwidth. Let's stop your video for a sec.
Yeah.
Try that now. I'm sorry.
Okay, sorry. Can you hear me now then?
Much better. Much better.
Yeah. Good. Thank you. Yeah, Michael, there was a person called Paulo Correa who was publishing in the 1990s with he was calling it a pulsed abnormal glow discharge reactor and claiming electrical energy obtained from plasma arc discharges. So is that a technology that you've had anything to do with or is related to yours at all?
I recall that one, but it was related to the research into ball lightning, if I remember correctly. Is that the one you're talking about?
Yeah, there could well be. Yeah, they used high vacuum tubes with aluminium plate cathodes and found that there was a particular negative resistance region of the arc discharge where they could obtain pulses or create pulses of electrical energy and achieved yeah, output exceeding input energy.
If I remember right, I've met and talked to Paulo Correa. Michael, I had thought that you were actually the person who introduced me to him, but maybe you just pointed me towards his stuff one day.
Yeah, I did. I recall that they were doing research into ball lightning, and one of the things that was interesting about ball lightning is that it persists longer than a normal discharge. And like a lightning, there's a discharge, and the amount of dissipation of the discharge is calculable directly. The amount of anomalous heat you get from ball lightning and the fact that it takes longer to discharge than is within normal calculations for lightning was one of the things that they were studying was what is burning in this plasma that is generating a sort of a quasi ground state that's able to sustain the reaction longer than it would normally if it went straight to ground. You understand what I'm saying?
Yeah,
I
think so.
In ball lightning, why does it persist above the ground? What quasi ground is it consuming or hesitating from going to ground? And that I believe is electronegative elements which are within the plasma, which are essentially being consumed within the plasma. And as they become electropositive, like hydrogen, dissipating as energy through hydrogen, evolving as hydrogen. Probably hydrocarbons, like literally swamp gas,
Yeah.
like a plasma from swamp gas. That's actually feasible. I mean, if you think about it, a methane plasma from a discharge of lightning being consumed by the energy from the plasma and as it decomposes into hydrogen.
Yeah. Okay.
And carbon dioxide.
Thank you. Yeah.
Yeah. So I think David. So I think we're all set there. I think we are again. We're almost at the top of the hour. And Michael, I want to thank you again for your time. Let me check in real quick and see if Mike Gamble wants to go. Mike. Okay. Do you want to do your presentation? Are you ready to do your presentation?
A little bit early, but no problem.
Yeah. Okay. Well, let me do this then. Let me do this. First and foremost, I want to put this thing back on gallery mode. Everyone, please give an enormous applause to Mr. Michael McDonough. I had to beg and grovel to get Michael to present. It was sad and pitiful, but I am so overjoyed that he came and presented for us. Michael, I would love to have you back. You have so many different ideas, and you've done so much different research. So I would love to have you back in the future. If and when you have something else to focus on.